particular lecture. And once it is declared, I won't teach it later. So please make sure that this shouldn't happen again. Okay, so I'll just revise what we saw in the previous lecture, and we're looking at Milne-Thomson method, which talked about getting a function in terms of z. So, as we were discussing earlier, our function f of z was written as u plus I v, where u and v are the functions of x and y, I times v of x, y. So we're discussing analyticity of a function. So a function is said to be analytic if it is differentiable in a certain neighborhood of a given point, then we'll say that the function is analytic at that point. So for checking the analyticity, we had the CR equation, which says that ux equal to vy, ux equal to vy, and uy is equal to minus of vx. So if these equations are satisfied in a neighborhood, then we say that the function is analytic. Once we are done with that, we saw that if f of z analytic, is analytic, then u and v are harmonic functions. Once I see that the function is analytic, u and v becomes harmonic functions, which means that ux x plus uyy, the addition turns out to be 0. Similarly, vxx plus vyy is equal to 0. So if the function is analytic, then u and v are harmonic functions. Then if in a certain function f of z, u is given, and it is said that f of z is analytic, then v is called the harmonic conjugate of u, so that u plus iv becomes an analytic function. So what we were doing was we were find v, and what was the method to find it is dv is equal to partial derivative of v with respect to x dx. So partial derivative of v with respect to y dy. Then we use the CR equation here. CR equation says that ux equal to vy and uy is equal to minus of vx. So we can put this inequality here, and I can put this over here. So that will give me minus of partial derivative of u with respect to x dx plus partial derivative of u with respect to y. This has to be partial derivative of u with respect to x dy. This is the exact differential equation, and the method we were using was v is equal to integration minus delta u by delta y dx. In this integration, y is to be kept constant plus integration terms of partial derivative of u with respect to x free from x and dy. So this is how you get the harmonic conjugate of u when v is given. If v is given, then the same things will occur. Just the reverse way substitution has to be there, and the process is almost same. This is what we have seen in the previous lecture. And while concluding, I said that you are writing f of z, and on the right hand side you have u x comma y plus I times v of x comma y. There is no z involved. So if I want to find function in terms of z, okay, if this analytic function I have to find, then we need Milne-Thomson method. So we also discussed this method, which said that you have u of x comma y plus I times v of x comma y. In this function, what we do is we put x is equal to z and y is equal to 0. Once we put this, I'll combine this and we'll get totally a function in terms of z. So whenever I want the right hand side in terms of z, what we do is we put x is equal to z and y equal to 0. This is the crux of Miles-Thompson method. So today what we need to do is we need to see, we need to write down that uh, Miles-Thompson method, and then we have to see the examples. So if you're writing down the notes, please note it down. So this again we have seen actually, but still I'll write it down. Z is equal to x plus iy, then the conjugate of it is given by x minus iy. Then x is equal to z plus z bar by 2, and y is given by z minus z bar divided by 2y. So if we write down f of z as u of x comma y plus I times v of x comma y, in this we'll put the values of x and y. So what we get is z plus z bar divided by 2 comma z minus z bar divided by 2I plus I times v of z plus z bar divided by 2 comma z minus z bar divided by 2I. So in this, what we do is we put z is equal to z bar. So once we put this in this above equation, what we get is u of z comma 0 plus I times v of z comma 0. So in this way, what we have got is we have obtained f of z in terms of z, and the f of z is analytic. So how to find the function? I mean, how to find a function f of z when u is given? Just like the previous examples where you had u and you find out harmonic conjugate of u, which is v, and then you say that f of z is equal to u plus iv is analytic. But there the problem is the right hand side is in terms of x and y, and the left hand side you are writing as a function of z. So it seems a bit incomplete. So if I want the function completely in terms of z, I should follow Miles-Thompson method. What does the Miles-Thompson method says? If u is given, say for an example, u is given to you, given, and what I need to find, I need to find f of z, which is analytic. Okay, so step one. Now what is the step one? Consider. How do you give f dash of z? We wrote this down as a remark. F dash of z is actually ux plus I times v. Okay, after the writing the CR equation, we wrote this. But by our CR equation, ux has to be equal to vy, and uy is equal to minus of vx. So this will be minus I times uy. So f dash of z can be given by this. Why I'm using this here? Because u is given to me. As u is given, I can find derivative of u with respect to x. I can also find derivative of u with respect to y. Once I'm done with this, step number two is step two is you find out ux, you will get something phi 1 of xy. Okay. In that, put x is equal to z and y equal to 0. Step number three, what we need to do is you partial derivative of u with respect to y, then I'll get say phi 2 of x comma y. Then put x is equal to z and y equal to 0. Once we put this, both the things, what we get is phi dash of z is equal to phi 1 of z comma 0 plus I times phi 2 of z comma 0. Once we get this, how will we get f of z? F of z has to be equal to, yes, tell me. Phi dash of z is phi 1 of z comma 0 plus I times phi 2 of z comma 0. So how will we get phi of z?
Sir,
Hmm? Yes, tell me Darshan.
सर z1 प्लस z बाय डिवाइड बाय 2 कॉमा ऐसा आएगा ना सर वो
Why? No. If you look at the equation, you will be able to tell me. F dash of z is given. How to find f of z? Okay. I'll tell you derivative of some function. So d by dx of u is equal to say x square. So u is equal to what?
सर 2x
Yes, Darshan.
सर 2x आएगा सर वो डेरिवेटिव का x स्क्वायर का
Samarjit.
Sir, integration of x square.
So that is x cube by 3. और f dash of z का मतलब क्या है? Is derivative of the function f of z. So f of z will be equal to the integration of phi 1 of z comma 0 dz plus I times integration phi 2 of z comma 0 dz. So this is the standard procedure. So what you are doing, you are given u, take the derivative of u with respect to x. Put x as z, y equal to 0. This is by Miles-Thomson method. Then take the derivative with respect to y, you will get another function in which you put x as z and y equal to 0. So you will get f dash of z. Once I get f dash of z, integrate with respect to z. That is my final solution. Clear? Now, how we go for examples of this? So, example. If u is equal to x square minus y square, then find v then find just a minute. Hmm. So if u is equal to this, find v such that f of z is equal to u plus iv is analytic. is analytic function of z is equal to x plus iy, and find f of z in terms of z, in terms of z using Milne-Thomson method. Okay, so we'll start. What is the method? First of all, take u. Once we get u, u is equal to x square minus y square. Partial derivative of u with respect to x is 2x. Partial derivative of u with respect to y is minus
minus
2y.
2.
Then what do we know? F dash of z is given by ux plus I times vx. But in this, by CR equation, ux equal to vy and uy is equal to minus of vx. So what v I don't know. So I will replace this term with respect to this. So what is vx equal to minus of uy? So ux minus I times uy. Put the values. So f dash of z. This is your phi 1 of x comma y. This is your phi 2 of x comma y. What we have to do before we put here? What was the method? Put x as z and y equal to 0. So put x is equal to z and y equal to 0 in phi 1 and phi 2. So what do we get? F dash of z is equal to 2z minus I times in uy, put y is 0, so we will get 0. This gives me f dash of z is equal to 2z. So f of z is equal to integration of 2z dz. What will be the answer? F of z is equal to z square.
सो वो 2z में 2 कहाँ से सब्स्टिट्यूट किया है?
It was 2x ना, phi 1 of x क्या है? 2x है. So if you replace x by z, what you will get?
ओके
Okay. So there are not just this type of example. In some examples, what we have to do is u plus v is given, u minus v is given. So in that case, we will have to use the same method but in different way. And before going to that one, we'll solve one more example where v is given to us. So find the corresponding analytic function for z is equal to, oh sorry, v is equal to e to the power 2x in bracket y cos 2y plus x sin 2y. I'll do that small calculations on the right hand side. F dash of z is given by ux plus I times vx. So ux equal to vy and uy is equal to minus of vx. What is to be replaced in this? V is given to us. So ux I will replace. What is ux equal to vy? So the answer is vy plus I times vx. Let's find out vy and vx. So differentiating v with respect to y. So vy is equal to e to the power 2x being constant. Come outside the derivative in the bracket y as it is. Derivative of cos 2y is minus 2 sin 2y plus cos 2y. Derivative of y with respect to y is 1 plus derivative of sin 2y is 2x cos of 2y. And differentiating with respect to x, v is equal to vx will be equal to e to the power 2x as it is in the bracket. Derivative of y cos 2y is 0 plus derivative of x is 1 sin 2y as it is plus the bracket as it is y cos 2y plus x sin 2y. This is the derivative, and derivative of e to the power 2x is 2e to the power 2. Now in this we have got vx, we have got vy. So phi 1, this will be phi 1. Oh sorry, this is phi 1 and this is phi 2. So phi 1 of z comma 0 is equal to, replace x by z and y by 0. So what will be the value of phi 1? E to the power 2z in bracket. First term will become 0. Cos 2 times 0 will become 1 plus cos 0 again 1 2z. What is phi 2 of z comma 0? Put x as z, y as 0. So first term is 0. In the second term, what we will have? Sin 0, 0. Phi 2 of z is 0. Please check the calculations. Okay.
सर अगर सर वो 1+2z कैसा है सर?
कहाँ पे
नहीं,
1?
2z समझे सर ये 1 कैसा है सर?
What is cos 0? You're putting y as 0 in this complete equation. Cos 0 will become, what is cos of 0? Cos of 0 is
1 सर.
that's why that 1 is there. So f dash of z is Vy, which is 0, plus I times Vy is, sorry, Vy is not 0. What is our Vy? Vy is this term. In this, when we put z comma 0, you get e to the power 2z in bracket 1 plus 2z plus I times v of x. V of x is this term. When you put z comma 0, it is becoming 0. So I into 0. So f of z is equal to integration e to the power 2z 1 plus 2z dz. What is the answer? So I will use generalized UV rule here. 1 plus 2z as it is. Integration of e to the power 2z is e to the power 2z divided by 2 minus derivative of 1 plus 2z is 2. Again, integration of this is e to the power 2z divided by 4. This is your of z. This is called the analytic function. Of course, you can simplify it. So I'll solve one example where u plus v or u minus v is given. And then what we have to do? That is what we will see. So example, if f of z is equal to u plus iv is analytic. And u minus v is equal to e to the power x in bracket cos y minus sin y. Then find f of z in terms of z. Then find f of z in terms of z. So what do we have? F of z is equal to u plus iv. What will be I times f of z? I times f of z is I into u minus v. So if I multiply 1 plus I to f of z, so this procedure will be same whenever u plus vu minus v is given. We'll multiply by 1 plus I1 minus I, this kind of thing, and we can go ahead. So when I multiply this, what I will get? U plus IV plus I times U plus IV. F of z is U plus IV. So when I open the bracket, we'll get f of z plus I times f of z. So I'll put the values here. U plus IV plus IU minus V. So how do you subtract two complex numbers or add two complex numbers? You collect the real part, which will be U minus V, and you collect the imaginary part, which will be U plus V. Am I clear up to this? Hopefully, yes. So this I can write as capital U plus I times capital V. Now you can see that V is with you. What is V? V is U plus V and capital U is U minus V. What is given to you? U minus V is given to you. So note capital U is equal to U minus V. है ना? So capital U, which is equal to e to the power x in bracket cos y minus sin y. So what we will do is we will follow the procedure where U is given to us. So whenever U is given to us, f dash of z, which is ux plus I times vx, ux equal to vy and uy is equal to minus of vx. So vx I have to replace by minus of uy. Okay, so I will have to find ux and uy with this capital U. Okay, and so capital U is e to the power x cos y minus sin y. What is capital U with respect to x? Which is e to the power x will remain as it is, cos y minus sin y. So put x is equal to z, y equal to 0. So what do we get? Capital Ux is equal to e to the power z, which I can call as phi 1 of z, comma 0. What is u with respect to y? U with respect to y is e to the power x as it is in bracket
Cos y.
minus sin y minus cos of y. Now put x is equal to z, y equal to 0 in this. If you put y equal to 0, sin 0 is 0, cos of 0, which is 1, and e to the power z. So what do we get in total is minus of e to the power z. So uy is equal to minus of e to the power z, which is phi 2 of z, comma 0. Now simply put the values. So f dash of z is equal to, it is ux e to the power z minus I times, what is uy, minus e to the power z. Okay, and what we started with is this. So in this example, we'll have 1 plus I times f dash of z is e to the power z minus I in bracket minus of e to the power z. So this is equal to 1 plus I e to the power z. So this 1 plus I will get cancelled out. F of z is equal to, so later I will integrate this. Just a minute, let me write this down a bit clearly so that it will be understood. Look, these calculations that we have done right now are for the capital U and capital V. We have to keep this in mind and then proceed. So I will write down capital F dash of Z in order to make this clear. So capital F dash of Z is equal to e to the power Z minus I times uy, which is minus e to the power Z. So capital F dash of Z is equal to 1 plus I e to the power Z. Okay. Now what is capital F of Z is equal to? Capital F of Z is equal to integration 1 plus I e to the power Z f of Z. Oh, sorry. 1 plus I e to the power Z dz. Now what is our capital F of Z? Capital F of Z is nothing but 1 plus I f of Z. So put capital F of Z is equal to 1 plus I f of Z. So once I put this value, I will have 1 plus I small f of Z is equal to, take the integration, 1 plus I being constant will come outside. Integration of e to the power Z is e to the power Z plus integrating constant C. Now 1 plus I can be divided to throughout the equation, and f of Z is equal to e to the power Z plus C dash, where C dash is equal to C upon 1 plus I. Darshan,
Yes, sir.
clear?
Yes, sir. थोड़ा sir.
Okay, I'll give one example. Let's see who can do it.
So just a minute.
सर वो माइनस साइन वो लास्ट सम में सर ये सर
हाँ,
माइनस साइन y और माइनस cos में कैसा है सर
कौन सा?
ये सर u y is equals to e raised to x ये वाला सर
I didn't understood what you're talking about.
सर वो जो है ना सर y सॉरी u y is equals to e raised to x ब्रैकेट
हाँ,
माइनस साइन y और माइनस cos में वो कैसा है सर
वो तो डेरिवेटिव है ना u का.
सॉरी सर
ये u यहाँ पे लिखा है, इसका डेरिवेटिव विद रिस्पेक्ट टू y लोगे तो ये आएगा. तो डेरिवेटिव है वो, उसमें कुछ डिफिकल्ट नहीं है.
ओके सर
Samarjit, should I go ahead?
Yes, sir.
Example. Now this you will have to do. U is given to you, y cube minus 3x square y. Find v such that, okay, just a minute, I'll change this a bit. Find f of z find f of z such that f of z is analytic. Just follow the same procedure, whatever we have done earlier, and tell me what is f of z. What is phi 1 of z comma 0? What is phi f1 of z comma 0? Phi 1 of z comma 0. कुछ नहीं हो सकता, कुछ नहीं. This is the final answer.
सर वो जो सर वो ये ना सर यू वाई सर उसका क्या है सर वो डेरिवेटिव वो पर बताइए ना सर
क्या क्या है?
तो क्या क्या है उसका डेरिवेटिव?
किसका?
सर वो यू वाई का।
ui का डेरिवेटिव कहाँ लिया हमने? ui खुद ही डेरिवेटिव है।
हाँ, तो फिर वो सर वी लिया है क्या हमने?
कहाँ पे?
वो सर वो यू एक्स के नीचे सर।
वो ui है ना। ui is itself derivative of u. I z cube plus integrating constant.